Welcome to the course on atomic structure and chemical bonding. It is a course in chemistry, and my name is Mangalasundar Krishnan, and I am a professor of chemistry in the Indian Institute of Technology, Madras. Understanding the structure of atom and the principles by which atoms are understood to form chemical bonds, they are a fundamental knowledge all science and technology students must possess. There are many levels at which this study can be undertaken. From your school days, when you looked at electron dots and the Lewis electron pair for bonding, to that of the most sophisticated theories that we have in quantum chemistry today, namely the solution of the Schrodinger equation as exactly as we can, and also a variant based on the electron density of the electrons in the atom, known as the density functional theory. In this course, of course, I shall provide a basis at an intermediate level, namely that of the basic principles and operational methods in quantum chemistry. I shall give the first few lessons are basically a primer in quantum chemistry for understanding both the valence bond as well as the molecular orbital method for chemical bonding. And to study these things, it is important that some of the basic principles of quantum mechanics are clearly understood and the model problems are solved. There are specific topics that you will find in the website. I shall solve in this course explicitly the problems of the particle in the box, the harmonic oscillator, the particle on a ring, and the hydrogen atom. You will also learn more on the differential equations, the second order and special differential equations that you will need to solve, and also matrices and eigenvalues and eigenvectors associated with matrices. Please feel free to ask as many questions as you can in the discussion forum. Two of my best PhD scholars are associated with this course, and I am quite certain that they would answer most of the questions, and I will also be available. Who do I address this course? Anyone with a basic knowledge in mathematics and physics at the class 12 level prescribed by the NCERT textbook. For those of you outside this country, NCERT stands for the National Council for Educational Research and Training, and the textbooks are provided by this National Council as curricula, suggested curricula for high school students, and also providing the educational pedagogy for learning at the school level. Approximately it is at the higher secondary or the sophomore level of students in the United States. I shall follow quite closely the syllabus recommended for final year undergraduates and first year postgraduates by the University Grants Commission, published by the UGC many years ago. There will be small changes in the course curriculum and the course plan to include things which I believe are important. It is an open course, and therefore the pace is also reasonably slow to medium, but do not expect me to rush through the course to give you recipes. I shall take the time to explain things. We will use a lot of animations for explaining some of the most important ideas, such as probabilities, wave functions, atomic and molecular orbitals, etc. I shall give you a couple of animations on some of these topics, and then you can have a much larger picture when you go through the whole course, and there will be many such animations and much more sets of them for you to actually play with. What you see in this picture is an animation of the atomic orbital, the pz orbital, which is given as a function cosine theta, where theta is the spherical polar angle, and you can see the animations similar to this for all the p orbitals and all the d orbitals as well as the f orbitals. In chemistry, these three sets of orbitals are probably the most important sets of orbitals for angular distribution of the electron wave function, and these are real parts of the angular distribution. So, you can see that cos theta in a spherical polar coordinate system appear like what you see in this picture. In one dimension, of course, the dimension is that of theta, the phi value is fixed here, and if you change the other polar angle phi for all the 360 degrees, you get exactly the cosine theta, which is the atomic orbital pz. You can see that in this animation. This is the p orbital. Now, in the plotting with both the coordinates theta and phi taken into account, and the sign of the function taken into account as well, and you see that therefore the plus and minus a half for a p orbital are shown in two different colors, as you see here. Another example is that of the d orbital, and many of you have seen the dz square orbital in the high school textbooks, and the dz square orbital corresponds to the trigonometric function 3 cosine square theta minus 1, with some constants of course multiplying for ensuring that it represents the wave function as well as a probability. 3 cos square theta minus 1 goes to 0 at some value, intermediate value at theta, namely you can see that here 54.74 degrees as well as 180 minus 54.74 degrees, and in that range this function is negative. Outside of these two values the function is positive. That is in one dimension for phi equal to 0. Now, if you play the same function for all values of phi, since it does not depend on phi, dz square orbital has the shape that you are familiar with, and these are accurate pictures. The course will contain many such pictures of the orbitals, of the wave functions and probabilities and so on. I welcome you to this course. An extremely important advice to the students: please solve every problem posted in the course as well as every assignment. Try to do it yourself. When you find the going tough, talk to another student, discuss. Assignments reinforce the concepts. Do not miss any of them. They pile up very quickly. Please remember, this is a 12-week course, and every week you have 1 or 2 assignments. Therefore, do not postpone your work. Quantum mechanics cannot be understood without solving all the problems that you have to solve. Even with that, it cannot be understood in the real sense of the word. We do not know why it works and changed the world in the last 100 years, of course. We only know that it works. Therefore, in this course I would share with you the learning and the joy and the fun of learning a difficult subject through illustrations, through problems, and also through conceptual introduction. I hope you will stay with me throughout this course. Look forward to having all of you with me, and thank you very much.